And good morning, everybody. Here are your notes for IXL.com. It's going to be Algebra 1, section BB.7. And the big idea is going to be using factors set equal to 0 to help solve quadratic equations. We did spend quite a bit of time learning how to factor problems back in modules. I believe they were AA, the AA section. We did a lot of factoring. For this particular module, it's already going to be factored for you. When we get to the next module, you will actually need to come up with the factors and then solve. But this will just be learning how to solve when it is already factored for us. So let's go ahead and look at a few examples. So the major concept is knowing that anything multiplied by 0 is going to produce 0. So you're going to be using that one fact that they call that the zero product property. So for example, if you had 3 times 0, then we know this is going to be a final answer of 0. If you had 4 times 0, then final answer is 0. So if you had anything times 0, it could be 1,000 multiplied by 0, then final answer will be 0. So if you had something that was unknown, for example 7 multiplied by some unknown value, call it x, and we know it's working out to be 0, what would x have to be? Well, we know anything times 0 will make the 0 that we're looking for, so in this case x would have to be 0. So that's the idea of the zero product property, that anything multiplied by 0 will make 0. So we're going to be looking to see where can our factors be 0. So we're going to have factors, and we're going to be looking to see where can they be 0. And let's just go ahead and do a couple more quick examples. So let's imagine we had these equations. Let's say we had 7 multiplied by something was 0. So what would x have to be? We would know that x needs to be 0 because 7 times 0 is 0. If you had 8 multiplied by some variable, let's say g, works out to be 0. What would g have to be? G would have to be 0. So you get 8 times 0 equals 0. So there's your solution for g. And what if you had something a little bit more complex than just a single variable? So what if we had something like 8 multiplied by x minus 2 needs to equal 0. So the 8 has to multiply against the parentheses, but it has to make a final answer of 0. So what we can kind of determine is that the parentheses, x minus 2, this value right here needs to be 0, so you get 8 times 0 equals 0. So x minus 2 has to be 0. So what kind of number would need to go in for x to make that set of parentheses 0? If x happened to be 2, you would get 2 minus 2 equals 0. And 2 minus 2 is 0 to get 0. So basically x needs to be 2. So if you plug a 2 in for x, the parentheses will become 0, and then 0 times the 8 is 0. Another example, let's say we have 7x minus 3 needs to equal 0. So what would need to go in for x so that our final answer is 0? We know we're going to need 7 times 0. So this will have to be 0. So what kind of number you need for x to make the parentheses 0? X would have to be 3. Because if you put the 3 back in for x, then you get 7 times 0, which is 0. So essentially you're going to be looking for what value would make the individual factors 0. So in this case, x would have to be 3, so that you get 7 times 0, which is 0. And let's look at a few IXL problems. So here is our factored form. In the next module, we'll actually have to factor the quadratic expression ourselves and come up with the factors. For this one, they're already factored for us. So d minus 9 multiplied by d minus 4 needs a final answer of 0. So if the first set of parentheses was 0, then 0 multiplied by the d minus 4 would be 0, because anything times 0 is 0. So what value do you need for d to make this first quantity, the first set of parentheses, 0? D would have to be 9. Because if you put a 9 in for d, 9 minus 9 is 0. So you get 9 minus 9 is making the 0. And then it doesn't really matter what the other set of parentheses works out to be. You could calculate it if you want to, but that would just be extra work. So 9 minus 9 is the 0. 9 minus the 4 is 5. But again, it doesn't really matter what this works out to be as long as we have our 0, because 0 times 5 is going to get you 0. So you're really just looking to see what values will make those parentheses 0. So the first one is going to be 9. And then what about the second one? How would the second set of parentheses become a value of 0 if d happened to be 4? Because 4 minus 4 is 0. So your two answers are going to be 9 and 4. So plugging either one of those two values back into the original equation will guarantee that your final result, your final output, is an output of 0. And let's look at another one. So the first factor is just a factor of u. So if u was 0, then 0 times whatever u minus 2 works out to be, doesn't really matter because u is already 0. You get a final answer of 0. And if u happened to be 2, 2 minus 2 would get you 0. So your two answers are 0 and 2. So you're just looking to see which value for the variable would make any one of those factors 0. The next one, what would q have to be? Q would have to be 3, because 3 minus 3 is 0. And the other factor, q would have to be 2, because 2 minus 2 would get you 0. This one's a little bit different. Notice we have a plus sign, so it's f plus 1. So what number would have to go in for f if you have f plus 1? And you're looking for that to be 0. So we're just looking at how can this factor be 0. Notice if you solve this, subtract 1 from both sides, f would have to be negative 1. You don't have to do the equation solving like this if you can do it in your head. A lot of people can look at this and just say, okay, if I had a negative 1 here, negative 1 plus 1 is the 0 that I need, so that would be negative 1. So we have a negative on this one. And the next one, it's f minus 5. So what kind of number do we need here to make that set of parentheses 0? F would have to be 5. So 5 minus 5 is 0. And here's the next one. How could this factor m be 0? M could be 0 if m was 0. And this is where people get to a point where maybe they can't do these in their head quite yet. How can 8m minus 3 be a value of 0 is what we're asking. And now you have kind of a quick little linear equation that you could solve. So you might have to go through a couple solving steps before you can do these in your head. So how would you solve this for m? So if you add 3 to both sides, so this is your basic two-step equation solving. So add 3 and then divide by 8. So m would have to be 3/8. So that's going to be your solution for m. So you want to put 3/8 into the solution box. So one solution was 0 and the other one was 3/8. So when you get to these, don't be afraid to make an equation out of it and actually solve it out to see what would make that set of parentheses 0. Here's another one, again getting a little bit higher in the smart score area, so more challenging problems. What would make these two factors 0? Just solve them both out. So 7f minus 5, how could that be 0? So what's your first solving step? Add 5 to both sides. So 7f would have to equal 5. And then keep solving for f. Divide both sides by 7. So f would need to be 5/7. So that's going to be one of the answers. And then solve the other factor and see how that one can be 0. So how can 3f plus 5 work out to be a value of 0? Subtract 5 from both sides. And divide both sides by 3. So f would have to be negative 5/3. So that would go into the other answer box. So when you get these types of problems and you can't do them in your head, set them each equal to 0 and solve each case. And here's the next one. The first one, you can probably do that in your head. What kind of number does q have to be to make those parentheses 0? Q would have to be a negative 2, because a negative 2 plus 2 would be 0. This one you might need to set up an equation and solve for where 4q minus 5 can make a value of 0. So how can that set of parentheses work out to be 0? Add 5 to both sides. And divide by 4. So q would need to be 5/4. And that's going to be your second value for q, so you just want to put 5/4 in the answer box. And here's another one. This one, 9 times k. How can 9 times k be 0? What would k have to be? K would have to be 0, because 9 times 0 would make the 0. So you're looking for where 9k can be 0. And k has to be 0 for that to happen. And the other one, you can probably do that in your head. K minus 7, how can that be 0? K would have to be 7, because 7 minus 7 is 0. And it looks like that is it for the examples. So you're basically looking to see how can all the individual factors be 0 so that the whole equation works out to be 0.